you should be on this page here. At the top it says notes for worksheet number 3, and it says ratios, proportions, and similar triangles. So we're still dealing with these similar shapes, but we're going to start talking about how do ratios and proportions play into these kind of problems and how we actually start to solve for maybe things that are missing on our triangles using a ratio or a proportion. And in the past, when we talked about what does it mean for things to be similar, and we talked about dilation, I use the word like proportional, or I said that they were proportionally changed. So all the sides were affected. That's why these proportions connect into our triangles here. At the top, I'm just going to write that similarity ties in with proportions. So they are connected to each other because when you're having similar triangles, that means that a dilation occurred, and a dilation is going to affect the entire shape. So it's going to be proportional all the way around. Now we've seen proportions so far. When you guys saw them, you had to like fill in a missing side from a triangle. So even if I just scroll back up for a second here, this is what we did last week. Something like this would be a proportion that I'm looking for. More so, this half of it is the proportion that we're going to be looking at today. Now, when you did these in the past, you only had letters involved. Today, there's going to be numbers because they're going to start giving you measurements for your triangles, and then you're trying to solve for a missing measurement. But we're going to use kind of this thinking that we did when we were trying to fill out what goes in the missing spot. We're going to use that similarity statement or information that we're given about the triangle in order to help me set up my proportion. But what a proportion is that it's two ratios, or we could also say fractions. So I'm going to put fractions next to that are equal. Remember, a ratio is basically a fraction. It's just written differently. It will say like 3 and then ... 5 or something like that, but that would be the same thing as 3/5. So a ratio and a fraction, they kind of go hand in hand together. We can write them both ways. And today when you read problems, you maybe will start out with something written in the ratio form, and you have to make it become a fraction when you're trying to do your proportion, okay? Now, you have probably seen proportions and you've solved them. I know you probably have done this in middle school. An example of a proportion would be something like 3/4 equals x over 6. And when you guys were in middle school, how were you taught to solve that? Yeah, did they call it something? The butterfly method, because when you circle those numbers, it kind of looks like the wings of a butterfly, okay? I'm probably not going to call it butterfly method, just because I think when we get to the high school level, most of your teachers are probably not going to say butterfly method. They're instead going to call it cross multiplication or cross products. And even going forward, if you guys start taking math when you guys are in college, they're probably going to talk about cross multiplication. They're probably not going to say butterfly method when you're in college. So when we talk about this, I usually draw it with a big X instead of circling. But if you guys still want to circle your numbers like I showed, that's fine. I don't really care how you figure out how you're going to match up your pieces. But you are doing like diagonal multiplication here. Okay, so let's do an example. The first one says that the ratio of boys to girls in the class is 1:3. If there are 21 girls in the class, how many boys are there? Now, some of you might already be able to do this mentally because you can just work with these numbers, but there might be times where the numbers get a little bit harder and you can't just do it mentally, or you might be dealing with some like decimals or something in your problem. So I want you to still try to think about how would I set this up as a proportion? Even if you can think about it mentally right now, how could we make this problem look like a proportion? Does anyone have thoughts on how I could do that? How do I get it to look like this form? 1 over 3 and x over 21, you said? How did you know to put like the x over the 21, or how did you know to like set it up this way?
Because it says boys to girls and then there's 21 girls.
Okay, so we're reading the problem for some key information, right? It says ratio of boys to girls is 1 to 3. So that really means for every one boy, there's 3 girls in the room. So if I'm setting this up, you could almost think I put boys over girls when I was setting up my fractions here. I could have switched it around though. I could have put the 3 on top and the 1 on the bottom, but then that will impact how I set up the second half of my fraction. Since they're telling me that there's 21 girls in the class, I have to keep that with the girls from my ratio. But I told my last period this, there's more than one way to set up this proportion. You could have done it like what we have up here. You could have switched it so it said 3 over 1 and 21 over x. You also could put the 3 and the 21 together in a fraction if you wanted to. You could say 3 over 21 and then 1 over x. There's a lot of different possibilities when you're setting up proportions, which is nice, but also it can be a little bit tricky for some students to know if you're setting it up correctly based on all the possibilities that could happen. Now we're going to cross multiply. And so you'd have 3 times x, which is 3x, and 1 times 21, which is just 21. And then what would you do? Divide by 3, and you'd get what? 7. So there are 7 boys. Again, you could check your work. You could put that 7 in for the x. You can reduce the fractions so that they're equivalent to each other. You could check the cross multiplication, make sure that those products are still going to be equal. Those would all be really easy, fast ways to check if you set up your proportion correctly and you got the right answer. Now, if you look at the second one, it says that a triangle has angles in a ratio of 1 to 2 to 3. And they're asking me to find the sides of each angle. Anyone have a thought on how we would maybe approach this one instead? What do you guys know or remember about angles in a triangle? Nothing? They have to add up to something, which is 180. Okay, so we know that the 3 angles inside of a triangle always have to add up to 180. This time I have a ratio. It's not like that first one where it's just 2 numbers. It's 3 numbers now. But so basically these amounts, these angle measurements that I started with, they were all able to be reduced. And when I reduced them, I got it down to this 1 to 2 to 3 quantity. So I'm going to take these 3 numbers. I'm going to use them to help me set this up, but I'm going to attach x's to all of them because x is going to represent the amount that they reduced all the angles by. So I'm going to write 1x or just x. I don't have to put a 1 in front of an x. Then it's going to be 2x and then 3x. But then we just reminded ourselves that they should add up to 180. So I'm going to put plus signs in between them, and I'm going to say equals 180 because that's what the angle should do. How many x's total do I have here? 6. So how much is x going to be? 30. They want to know, though, how much was like the size of each angle. So what should we do?
Centimeters.
Plug in x for all of those ratio quantities up above. So it would be 30 degrees, and then what? 60, and then 90. Some problems, though, just to kind of go off of what you had said, will require labels. Like you have one on your homework today that talks about perimeter. Perimeter is the distance around a shape. So when you're maybe talking about what the perimeter is or how long the side lengths are on that shape, make sure that you're grabbing a label. If we can label something with centimeters or inches or something like that, we would want to. But it really just depends on the context of the problem. What are they asking about? All right, do we have any questions so far on setting up those proportions from ratios? Okay, so if you guys come down here to the next 2, Now they're going to start giving you pictures of these similar triangles. So instead of writing it all out in words, they're going to start giving you an image, and we have to use the information that's on there to help me set up my proportions. Now, if I look at this first one, in the directions, what are they giving you that might be helpful?
What triangles are very similar?
That they're similar. So they're giving us this similarity statement right here. And remember, when we use that, that helped us kind of know what side should go with what sides. You may want to use that to help you know that you're setting up your proportions in the right order or the right way. Because on the picture, there's just a lot of numbers. There's nothing marked for my angles to let me know what should go with what. So they provided me with this statement up here. I'm probably going to need to refer to that to make sure I'm setting up my proportions correctly. Now, how many variables do you see down below? How many letters do we have to solve for on this problem? 2 of them. We have an X and we have a Y. So I want to solve for each of them separately. Now, I don't want to have a proportion that has an X and a Y both in it, because then you're going to get stuck and you can't do anything when you have 2 letters. So I want to focus on 1 letter at a time. So let's start with the X, okay? What could we maybe put this X with? From maybe if we're thinking like small triangle to big triangle, what would the X go with? 8. Now, they look like they're in the same position. I could use my statement up above to help me make sure I set this up right. ED are the first 2 letters here, and so that should go with AB on the other triangle, which is that 8 side. Now, where would you like me to put the 8? You want it on top with the X, or do you want it in the same fraction as the X? The same fraction? It doesn't really matter where you put it. The only place you can't put it is here. You can't put the X here. It should not be diagonal from the side that it's connecting to. They either need to be on the same level, so the 8 could have come up here, or it's fine to put it there. Okay, so now on the other side, what should we use? I need some numbers.
3 and 1, or 2 and 5.
2 and 5? I agree with 2 and 5 because I do think those sides go together. Again, I'm just looking at my statement. The 5 is on BC, so that's those 2 letters, and 2 is on DC, which is those 2 letters. So I do think those are going to match. What should we put on top with the X?
2.
2. Why did you say 2?
Because it's on the same triangle as X.
It's on the same triangle as X. So when you're setting up proportions, you kind of got to really think about keeping like pieces together. So in this case, the X and the 8 have to stick together because they connect the triangles, but the X and the 2 also need to stick together because they come from the same triangle. You could also think I did small triangle over the big triangle when I set that up. All right, if I cross multiply here, I get 5x equals 16. I'm not going to get a nice number. It does not mean that we did it wrong. If you get a decimal in math, it doesn't mean that you're wrong all the time. I mean, sometimes decimals aren't right, but it's okay to get a decimal, especially when you're working with these proportions. You may not get it to work out nicely all the time. You might want a calculator. Anyone know what that is, though? 3.2? I have 2 written down. Can someone check it? Is it 3.3 or 3.2? I just want to make sure I have the right thing. You confident, Brady? If you need a calculator, let us know. We've got plenty in the back. We could get you one if you don't have one of your own. But you might want one because there's going to be some decimals that show up in our problems here today. Okay, how could we set up a proportion for the y? Y over 3 equals?
5 over 2.
Good, 5 over 2. This time we kind of switched it since we put y on top. That's from the big orange triangle. And then the 3 is from the small one, kind of that, I guess, purple-ish color. So y over 3 is like now big over small. So we then had to switch the 5 and the 2. We have to flip that around too to reflect that we're switching our proportion. Okay, if we cross multiply here, you get 2y equals 15. What do we get?
7.5.
Good, 7.5. Again, you could be plugging these numbers that you found for x and y. You could put them back up here into your original proportion, and you could be cross multiplying to check that way. You could also divide, like 3.2 divided by 8, 2 divided by 5. Those should break down to the same amount. So understanding that that would be a really quick way to check something and that it should all kind of flow and make sense is something that you could be doing anytime. All right, I would like you guys to look at number 5, and I'm going to give you like 2 minutes. I want you to try to do what you can with it. And if you change your mind, you need a calculator, let us know, because me or Mr. Akers can grab you one. So if you need one, just put your hand up and we'll bring one to you. All right, I'd like to talk about these here. Do they provide you guys with a similarity statement this time? No. What do they give you, though, that maybe will be helpful? What are those marking? The angles, okay? So like the O's, the little stars, that's telling you that like those angles match. What do you guys know about these angles here? They're vertical, which means they should be congruent. They should be the same as well, okay? So they're not marked. If you guys wanted to, you could add that in. Like you could put an arc here and an arc there. You could mark it with another little symbol if you'd like to. But I would use that information to help me set up my proportions, okay? So I'm going to look now and try to figure out a way to set up. Let's start with x. Can you guys tell me what you did? Leah?
Put x over 6.25 and then set it equals 1.
Okay. If you had yours set up differently, that's okay. But one way to check yours to make sure that you did it right is that the x and the 5 and like the 4 and the 6.25, those should be diagonal from each other. So regardless of which order you kind of put them in your fraction, those numbers should always be diagonal. That lets you know that you did it right. And then if we cross multiply, what'd you guys get for x? 5? Okay. Someone tell me how they set up y. Anybody? Don't make Aaliyah do it again. Brady? Well, tell me what you did. Okay, y over 4. Well, let's just check that really quick. See how this has an open circle and we're talking about the vertical angle? So that should probably go with the 3 instead, because that's between the open and the vertical angle as well. So I think we want to put those together instead, and then that's just going to switch that side. But that's okay. Using those markings is going to help you make sure you put things in the right spot. So if we do y over 3 instead, and then you could do 5 over 4. That's using the same piece as I think you said. It's just putting it in a different order there. If I cross multiply here, what do I get?
3.75.
Good, 3.75. So when you're setting those up on triangles, really watch, like if they give you a similarity statement, use that, because even the way that these two look was different. Like on this first one, the 5 and the 2 went together. This one over here, the 5 went with the 4. They switched kind of how those triangles were positioned in the picture. They're going to do that to you. They're going to go back and forth. So just use the similarity statement or use those angle markings to help you make sure you're putting things in the right spot. Does anyone have questions?